The last system that we're going to look at for the Rankine power cycle is going to be the condenser. The condenser is the unit which is rejecting heat to the surrounding environment. So the purpose of the condenser, there are actually a number of different purposes. One of them is we want the condenser to be operating at a low pressure, and that is the pressure at which we expand the steam in the turbine to. A second thing is we use the condenser to be able to condense the steam. So if we still have steam left in the exhaust from the turbine, we want to take that back to the liquid state because we don't want vapor going into our pump. We want all of the fluid going into the pump to be in the liquid state. And so a second purpose and a third purpose of the condenser is to deaerate the condensate. So that is to get rid of any of the residual oxygen that might be in the working fluid. So those are three of the main purposes of the condensing unit. And these are basically, when you look at them, they're basically just heat exchangers that you would see similar sorts of things in a course that you take in heat transfer, for example. So when you study heat transfer, you study condensing units, and that's essentially what the condenser is. And so if we were to draw a profile similar to what we would do in heat transfer, looking at the flow of fluid from the inlet to the exhaust, what we would find is one of our fluids is remaining at the saturation temperature. So that would be the fluid coming out of the turbine and then going into the pump. While we have another liquid that's gaining thermal energy through this process, and consequently its temperature will rise, and that is our circulating water. Now, what we want to be able to do is we want to be able to reject this thermal energy from the circulating water. So it's starting at a lower temperature, going up to a higher temperature. When it comes out here, we then reject that to some other medium, and that is usually rejected to the atmosphere. So what I'm going to do now, I'm going to show you a couple of video clips of units that are used for rejecting thermal energy as part of large thermal power plants. So let's take a look at those videos. There you can see the cooling towers from the nuclear reactor. There are 8 cooling towers there. I wonder how many megawatts that is. That's quite the big power plant. probably quite close to the Austrian border. I think, what, we're 70 kilometers from Bratislava?
Yeah, I think so.
Máte väčšiu nový telefón, poďme na tú druhú.
Get a good view of the power plant from here. Wow. So what we saw in the video were two very different systems for rejecting thermal energy to the environment. And in those applications, our circulating water was rejecting the thermal energy. And the first one, that was a nuclear power plant near Vienna, actually near Bratislava in Slovakia. And you could see the natural draft cooling towers that were part of the nuclear power plant. So those would be rejecting significant amounts of thermal energy. And the second one was a spray pond that was part of the sugar mill in Maui. And so there they were rejecting thermal energy. Spray ponds aren't used that often because they do waste water through evaporation. But nonetheless, you saw the principle of it. You spray the water into the air, the water cools through that process, and then you recollect the water, and that's how you're rejecting the thermal energy. So those are two different types of applications, and I apologize for the shakiness of the one in Trenchant. That's the one that was near the nuclear power plant. That was taken during a family vacation. Actually, they were both during family vacations, and we were on the road and it was a little bumpy, and you got to listen to a little bit of Michael Bublé through that video. But anyways, what we have is the circulating water. We want to be able to reject the thermal energy. And common things that power plants will use is you might use a nearby lake or river. You could use the atmosphere. So in the case of the nuclear power plant with the natural draft cooling towers, there we were using the air as what we were rejecting the heat to, as with the spray pond. And a third way that you can reject the thermal energy that we have not yet covered is through cogeneration, whereby you would reject that thermal energy for space heating with some location nearby. And we will consider cogeneration in a later lecture when we look at a system whereby we're rejecting the thermal energy for municipal heating. But with that, that concludes the different components of the Rankine power cycle. And that concludes the lecture. So thank you very much.